Well, hi, and welcome to the Smart Building Series, and this, which is our second free webinar in 2018. And today we are talking about artificial intelligence in the boiler room. And first, I just want to say a big thank you to our sponsor, Project Haystack. They are an open source initiative who are streamlining working with data from the Internet of Things. It's a really interesting project, and I recommend that everybody go and take a look at what they're doing and get involved if you can. So you need to go to project-haystack.org for that. And obviously, we record all our webinars. So if you want to listen again to this or you want to share it with any of your colleagues, then it's going to be posted on SoundCloud. We can also be downloaded as a podcast from iTunes, and also on YouTube. So just simply search on any of those for Smart Building Series and you'll be able to find us. And last thing, of course, questions. If you guys have any questions, then please type them in. I'd like to welcome Sri Deivasigamani from CEO Intellihot. Hi, Sri. How are you doing?
Hi, good. Very good. Thank you.
Great.
Very happy to be here.
Yeah, and it's going to be a good talk. I'm looking forward to it. So the way we're going to do this is Sri is going to give us a presentation about what he's been working on and some really insightful slides. And then after that, we're going to take some Q&A, some questions from you guys. So please, if you do have questions, the way that we do this, if you can type them in, I'll get the questions here, and then we can put them to Sri. So yeah, Sri, please tell us about yourself and Intellihot.
Absolutely. Thank you. Well, hello everyone. My name is Sridhar Deivasigamani. Quite a long name. You can call me Sri for short. I am dialing in from Peoria, Illinois, which is about 3 hours southwest of Chicago. And it's about 1 degree centigrade and 34 F. We call it a nice sunny, balmy day here in central Illinois. My background, I'm a mechanical/mechatronics engineer by trade. And I relocated to Peoria. This used to be the world headquarters for Caterpillar. Worked on diesel engines, autonomous machines, lots of robotic stuff. And many years ago, a water heater broke and flooded my house. And what was a short weekend project turned into a company today. And what we do here is we turn simple things like water heaters and boilers and other devices into smart devices. So today we build on-demand water heaters for the commercial industry. We also build other devices that can go into your boiler room, which, as you will see today, can connect to your existing water heater or boiler or your rooftop unit or maybe a furnace, and instantly turn those devices into a device that is very meaningful and gives you data and keeps you and your customer happy. So that's what we're going to talk here. I am excited to share some thoughts and ideas with you, and I'm looking forward to taking your questions as well. So with that, we will start. The topic today, as I mentioned, is AI, and there's a lot of definition around AI, and we'll talk more about that further down. Now, this picture here might be pretty dated, but I'm sure many of you recognize HAL 9000. It's from Space Odyssey. And if you see any of the trends that are going on, things are getting more automated. So we do expect sometime in the future that, a bunch of robots might be in your mechanical room, and they might even make some phone calls for you. So here's our objective. I want to be respectful of your time, and thought we'll have a little bit of fun trying to learn about and sharing ideas on machine learning and automation. So we'll talk about terms like M2M, API, MQTT, and obviously, I saw some recent studies on how addictive the cell phones are. So one of the objectives will be try not to hit refresh on your iPhone. So let's see how that happens. So the real objectives today really are, what are the safety and monetary risks imposed by boiler rooms? Everybody is familiar with boiler rooms, which host all the mechanical equipment. Can we use AI or machine learning to cut our operating costs? And then, the biggest thing is, how do you prevent costly downtime? So if you are in the business of managing energy for your building, the three questions you ask are, is everything okay? When do I need to change stuff? And when will things break down, right? So we're going to help you with all three of those today. Now, before we get started, I want to give you a little bit of perspective. Now, in the last century, these are the top 10 things, and you may make your own list, but I'm pretty sure it'll fall in. We built rockets. We went to the moon. We invented nuclear power. We invented the personal computer, television, antibiotics. Obviously, the internet came into being, radios and cars. Lots of exciting stuff, right, in various fields. However, if you look at the boiler room, fundamentally, since James Watt invented the steam engine, it's relatively remained the same. You got fire, you got some kind of fluid circulating around it, absorbing heat. You got to expel the burnt gases. There could be leaks of hot gases, leaks of water, leaks of fluid, carbon monoxide leaks. Fundamentally, the situation there hasn't changed a whole lot. But after today, you will see that there's lots of opportunities to really disrupt in the space. So any mechanical room you walk into, these are the three elements. The first and foremost, you want to ensure that your mechanical room is operating safely. And you have a mix of three elements. You have some kind of fluid, could be a boiler fluid or water. You got electricity, and you got some kind of carbon-based fuel. Could be natural gas, propane, oil. And obviously you have combusted gases, ventilation. These three elements don't mix well together. So as a result, a typical boiler room is obviously at risk from water leaks, carbon monoxide, and gas. And when you step back and think about it, certainly in the US, we burn a lot of fuel to heat our water, to heat our buildings. And according to DOE estimates, we are burning $50 billion more than what we should. So that's a lot of energy that's being wasted. Now, we have made some advancements, and there are condensing boilers and condensing water heaters. And obviously, for those of you in the field, you might be familiar with the condensate that comes out of these devices. It's slightly acidic, traces of sulfuric acid, carbonic acid, nitric acid, but has to be discharged. However, millions of gallons of it we find are being discharged untreated. And as the popularity of these devices, condensing boilers, increase, this problem gets exacerbated. Now, in terms of what happens, typically you'll see this in the news. There is some kind of boiler explosion that's happening typically once a week. Some explosion that happens either residentially or commercially. And then obviously lots of leaks from boilers and water heaters or storage tanks, all pretty common sights. From the condensate's perspective, which all these condensing boilers and water heaters produce, if they are not treated and if their pH is not neutralized, they end up corroding drains. And obviously, certainly the EPA is worried because we are dumping millions of gallons in the environment, and we could have an environmental risk. So again, taking a step back, if you look at least certainly in America, carbon monoxide results in the number one emergency room visits. The US averages about one boiler explosion a week, and in terms of fluid leaks, at least 3 shutdowns per year. Obviously, this causes significant risk to your customers and to yourself as a business. So how are we addressing this today? So we got water heaters or boilers, got a bunch of isolated gauges. And when something goes wrong, if it leaks, we call the technician. He would come there, run a bunch of tests, fix certain problems. And mostly we are in this break fix mode. Now we do have some kind of alarms in building. Might be a gas alarm or a smoke alarm or even a water leak alarm. Typically, in the majority of the buildings, they produce an audible alarm, which you can hear only if you happen to be walking around your mechanical room. So it's a very, very small percentage of mechanical rooms that are wired. And even if it's wired, it might be some kind of building management system, and it doesn't really push those alerts to your phone. So we have what I call information and control isolation. So we have a bunch of static gauges that don't really tell us what's going on or what's going to happen. And the thinking is pretty simple. If we don't measure it and we don't measure it actively, we can't manage it. As a result, we are terribly inefficient. So productivity is poor, we waste time, money, and resources. And in terms of safety, this is a big portion of our mechanical rooms. Gas leaks, carbon monoxide leaks, they are typically devices by themselves. They do not hook up to your water heater or boiler, right? Nor do they communicate to the external world. There is no remote access. In terms of neutralization, we have these very passive devices. Majority that we found do not treat condensate properly. There are lots of fundamental design flaws. One of the most common ones is when condensate comes from a boiler, it tends to be warmer. And so what happens is the hot condensate typically skims the stop without even going through the neutralizing media and then exits without being treated. That's a common problem. A lot of these media, when they get used up, the device does not report back that media needs to be replaced. So again, the condensate exits the mechanical room without being treated. So anyway, to summarize this, we find mechanical rooms, boiler rooms are prone to gas leaks, water leaks, carbon monoxide leaks. Equipment runs inefficiently, and condensate is obviously a silent destroyer. So we have a big problem on our hands. So here at Intellihot, we think outside the box, and since we ourselves make a condensing boiler and a water heater, we asked ourselves, we got to do something about this. We can put our own devices and have them, pollute the environment and have them be at risk. So we started with a very simplistic idea. What if we took a bunch of sensors, gas sensor, carbon monoxide? What if we combine them? And then what if we added a couple more sensors to it? Let's say we add a couple of temperature sensors, which can sense either air temperature or boiler return and boiler supply temperature, maybe water in and water out temperature. Maybe we add a non-intrusive flow meter to this. So we got data from these devices coming into this. Now, with all this data coming in, what if we add some kind of learning, machine learning and intelligence to it? What would happen? Well, we can do something useful with it. So the most common thinking is, well, if something goes wrong, I should at least be able to turn off gas and water, maybe even power. So all right, we'll add some valve actuation to this yet to be determined device. And while we add actuation, why not we add some interlocks? So if there is a gas leak, which typically a mechanical room is prone to, or carbon monoxide, we have to turn off the equipment that's causing it. So let's connect it to the boiler through an interlock. If we did all that, it's still not good enough, is it? Because we have to get that information to us. And as you can see, that's a picture of my cell phone, and apparently I have 11,900 emails that I haven't read. So if you ignore that, we have a way of taking all the data from this device and pushing it to your cell phone. And there are lots of ways to do it. common method is called MQTT, where this device will collect a little bit of data, even do some insight processing, and then push it to the cloud. We did all this, and we came up with a device that looked like a little robot. In fact, we loved it so much, we called it the Telebot. And here's what the Telebot does. The Telebot is able to measure temperatures. It can, it can sense leaks in a room. Could be glycol leaks, water leaks, condensate leaks. It could sniff for gas leaks, carbon monoxide, and you could even connect a flow rate, a flow sensor to it, and it could measure flows. And you could connect temperature sensors and measure inlet and outlet temperatures. So right off the bat, let me share with you, while you don't have to use this as a condensate device, here is how it fundamentally treats condensate. The condensate from any device, should you have one, comes in at the bottom. It rises up, goes through the neutralizing media, and then it's forced to go down. And then we measure the treated condensate using a pH sensor all actively. So fundamentally, we know the condensate is going through the media, and we double check it towards the end. So that works great. And in terms of the other sensors, I talked about carbon monoxide. All those sensor connections are lined up on one side, and there are simple clips that come with this unit, and you clip it, and it takes less than 15 minutes. And what you would do is you would attach these temperature sensors to your boiler or water heater. If it's your boiler, it could be supply and return. If it's your water heater, it could be water in and water out. We even have an auxiliary temperature sensor that you can use to measure air. And something wonderful happens when you connect these sensors. And I'll talk about that in just a little minute. What I will tell you is the Telebot has gotten smart enough that by monitoring the perturbations in temperatures and flow, we are able to take that data and then convert the data into many, many useful things. And I'll share with you in just a second. The way, again, we talked about this, should you have a leak, here is how you would connect this device to turn off your gas or water. Comes with a clamp-on flow sensor so you can measure flow. So first off, right off the bat, from a safety perspective, you are covered because you're measuring gas, water, leaks, and you have the ability to actually turn off the device or even turn off water, power, and gas. In terms of the environment, you're measuring the condensate, so you're always in control. And the device itself, if you look on the right-hand side, you see where it says media run out. So the device is sort of learning how much condensate is flowing through the unit and when will the media run out. And it's going to send you a little ping saying, hey, John, look, your boiler is running 3 hours a day and you better change the media in the next 6 months. So that's pretty useful information, right? Now, all this information is obviously ported to your phone, and you can get these alerts. You can even monitor certain parameters and even remotely turn off equipment if needed. Now, look closely on the screenshot on the right-hand side where it says boiler room smartified. It's got a couple temperatures and flow rates. And beneath that, you see 3 little icons. The first one is called the ideas icon. The second one is called usage. And the third one is called service. So let me talk to you a little bit more about what the usage icon is. Usage pretty much tells you what's happening in the building. Here's historical information about temperatures. Here's what the flow looks like. Here is what the estimated energy is based on what this building has consumed. Now, this data is very, very useful because your customer could right away see, based on data and facts, how much energy are they using. Is their current equipment sized appropriately? Is it oversized or is it undersized? They could even see what days of the week or the month is my building most active. Lots of very, very useful information that you can use to understand your own business today. You could set up what I call IFTT, if this, then that. It's very, very simplistic. If I have a gas leak, should I turn the water heater off? If I have a water leak, should I turn the water off? You got all this flexibility built into the app, and this little device which is connected to your water heater or boiler will do that for you. And then you can set things like temperature ranges and flow ranges, and then have the device send you an alert in case any of these parameters go out of whack. All this is great, right? But I think I call this sort of a faster pigeon strategy. All we have done up to this point is get the information that's already there, and we have made it faster, and it's accessible to you on your phone. Nothing more than a faster pigeon. The pigeon now has taken, has gone to the speed of a supersonic jet. That's pretty much it. Now, here is where things start getting interesting. This is the stuff that's really, really exciting. So remember the sensors we talked about earlier, the temperature sensors and the flow sensors, even carbon monoxide sensors. Now, the system is capable of observing and monitoring all those temperatures. It is connected to the internet, so it knows outdoor air temperature. It looks at historical information and can know what a typical groundwater temperature is. So what it does, and on this screen, when you install this, we have a couple choices. You would say, is it a boiler system, is it a tank system, or is it a tankless? And then you put in these parameters, and then based on these, the information that the sensor collects, it learns the behavior. The behavior is classified as what is normal and what is not. And this is where things get very interesting, and we start to get into the world of AI. And I'm sure many of you have heard the word AI and lots of different terminologies. So I thought I would take a crack at sort of defining it. And again, this is a field that's rapidly changing. So these definitions are not exactly set in stone. But AI, in a very broad perspective, the desire for human beings, certainly for my wife, is for me to think. Certainly the machine should think, right? So the desire is, let's enable computers to think like how human beings think. So that's AI. Now, machine learning, which is a subset of AI, one portion, really involves a lot of statistical tools. So the tools like I shared with you before, I could look at what is the flow rate in my building, and is it most often on a Monday versus Sunday? Should I turn on certain pumps based on that? That's loosely defined as machine learning. Typically, you'll use a lot of statistical tools, 1 or 2 dimensional data for that. Now, there is something called deep learning, and this is a field that started in the late 90s when computers started to get a little bit more powerful. And machine learning is where, as human beings, we can very easily interpret 2 or 3 variables, right? If gas prices go up, my bank account is going to go down. If gas prices go up and my furniture looks bad and my wife is upset, maybe I got to get new furniture. My bank account is going to go down, right? 3 things. Now, in the machine world, you might have, or even in the business world, you might have 10 or even 15 parameters. You could have air temperature, you could have currency fluctuation, you could have occupancy rates, you could have a football game that's happening. All these parameters in one way, shape, or form affect your mechanical room and your business and how we supply energy to buildings. Now, when we take all these parameters and we mesh them all together, we can use what's called neural network, multi-layer neural network, and learn the correlations between these various parameters. So that's called deep learning. Now, there is also data science. Data science might float between deep learning and machine learning. Deep learning and AI. Typically, data science is what are the different ways I can visualize and understand the data. So that's a pretty high level view of what is AI. And now I'm going to share with you how AI, I'll give you a couple examples, how AI is being used in the boiler room. Now, remember that little ideas icon that I shared with you? In fact, for those of you on the phone, you could go to the App Store today and you can download our app. It's called Intellihot, T-E-L-L-I-B-O-T. And you can download it, you can sign up, and we have a demo unit there, and you can play around with it. In fact, I would encourage you to do so, to explore the possibilities. That little ideas icon is where magic happens. For example, based on the temperature sensors and based on observing the inflections and based on what the boiler is doing, the unit would actually learn, if I had about 1,000 cycles, and if this were a boiler, and I had about 30 seconds of pre-purge, that I'm evacuating the combustion chamber, then I fired really hard for about 15 minutes, and then I post-purge for about 30 seconds, and if the air temperature happened to be cold, it is a right condition to have a warped electrode, right? I'm sure you all know what a warped electrode is. When you heat and cool an electrode and you do it in rapid succession and you do it at the right temperatures, it can result in the electrodes, fraying. But the only time we would know about it is when your boiler does not fire, right? Now, if we applied AI to this problem, we supplied it with all kinds of information on here are the cycles, here's the purge times, here's the temperature, here's the air temperature, here's how long I fired. And then we can feed it data on the conditions under which we've observed the electrode to have warped. It can crunch this data and then start making predictions on what other conditions can you have warped electrode. So that's one example of how we are using AI in the boiler room. Here's another example. This pertains more to water heaters. For example, the way water is consumed, it's consumed in a very transient form. If you have a 100-room hotel, you might have very low consumption rates in the morning. It might then go up to a peak flow rate, and then it might come down. And depending on how your equipment is sized, you might have a lot of firing cycles. Now, in an ideal world, you want your equipment to sort of follow the load, right? Which means you need to have a boiler or a water heater with high modulation rates. Now, whatever system you have, the AI in the Intellihot can look at the firing cycles correlated with the minimum and maximum flow rate, figure out how long is the duration between peak flow to maximum flow. Does it happen on a Sunday versus a Monday? Is it consistent month over month? Is there any relation to groundwater temperature? It can do all this, and it can present you something called, hey, look, I have analyzed this data, and I think if you had equipment with greater modulation, say 50 to 1, you potentially stand to save $7,500 per month. Now, wouldn't this information be very, very useful for your customer? You could walk in the door and say, look, we have measured certain parameters, we've observed it, I've crunched the numbers, and based on that, I can very reliably tell you if you put in this type of equipment, you are actually going to save, $7,500 a month. So you remove the guesswork, and you're able to size things properly, as well as achieve a very high comfort level for your customer and a very high economic value proposition. So that's what AI can do for you. And there are many other examples. I thought for purposes of today, we would start with just two. And in terms of how we can apply this technology, it can be applied to pretty much any HVAC equipment, water heaters, boilers, furnaces, rooftop units. And really, there is no limit to what we can do with this. Now, here is a quick look at value proposition. Obviously, there is life and catastrophe involved, so there's significant, savings or priceless, should I say, there. But even if you had 50 installations with 100 boilers and you assumed a 10% failure rate, the amount of money you spend on a device like a Intellihot, you get a return of almost 14x. Significant value proposition compared to the investment you have to make. So in conclusion, what we are able to do with this type of technology is monitor fleets of properties. You can keep your boiler room safe. Obviously, the most exciting thing is being able to predict when things would happen, so you can prevent downtime. And obviously, you can cut operational cost with whatever equipment you have today. So with that, we will turn it over for questions.
That is great. Thank you so much for the presentation. And yeah, as Sri said, anyone who wants to ask any questions, please type them in. I'll get them here, and then we can put those questions to Sri. Yeah, really interesting. I mean, I've learned a hell of a lot. I mean, obviously what we cover in the research we do is more on the HVAC side, building management systems, but it's really interesting to see, how we are in quote unquote, smartifying different types of equipment in building. And I thought it was, it's really pertinent, I think, to how building technology is progressing. One of the things I was thinking of, from looking as we do about Internet of Things in buildings, like how could you integrate this data? That let's say if somebody installed some of your equipment, how could they integrate that with other types of, let's say, a building management system?
That's a great question. So the whole idea was we wanted this information to sort of come out of the mechanical room and be accessible to people. We can certainly port this over to traditional BMS, but the path we have taken really is let's push all this data to the cloud. And AI does require significant computing power, which is available in the cloud. And certainly the approach we are taking is we want to have information very easily accessible to people. So we are sort of viewing BMS in a sense as a legacy system, and IoT and looking at it on the cloud as the future.
Right. So there's some kind of cloud application that people can log into to view the data from their Intellihot. Is that right?
That is correct. So you could go to the Apple Store today, and you can actually download the Intellihot app. And we have a demo unit in there, and you could play around with the unit and see all the things that this unit does. You could set up temperature ranges. You could look at the flow ranges. It'll even make predictions on, based on whatever data it's collected, how can you optimize your existing equipment? And you get all of that in the palm of your hand.
Okay, great. And then maybe that's something for the future, but I was just thinking if there was an API, then, people could get hold of that data and then use it for, to maybe put it together with other information about the building. But yeah, I mean, it's all just being able to, as you said, being able to measure what's going on in the building. If we can't measure it, then we don't really know what's going on, do we? So yeah, that's I think is the most important point. Some questions have come in, Sri. One here: how many conditions has the AI been trained to identify, and what is the performance of the AI? And by that they mean false positives versus true positives, recall, etc.
Great question. So we have started out with a very basic list. So if you are in your mechanical room today, you think about all the stuff that breaks down. typically breaks down without warning. Blowers, gas valves, electrodes, fouling, cavitation. So all the basic conditions that you see today, failure to ignite, for example, potential loss of supply. We are able to detect all the very, very basic conditions. And the way we are able to do it is not upon failure. We are able to detect and sort of forecast when things would happen. So as in the case of the electrode, if we observe conditions where the unit is behaving in a certain way, is behaving mostly during the day and depending on temperatures, we would actually recommend that you inspect the electrode even before the electrode is warped. Or maybe it started to warp, but it's not gotten to the stage where your unit would be completely shut down. So all the typical conditions you see in a boiler room is what we're working on today.
Okay. Is there any example of, for, let's say, is it 90% that you could predict a, failure with an electrode, for example, something like that? Or is it, have you been able to measure that?
We are in the process. There are some items we are really, really good at. Electrode, bearing life, failure to ignite, number of firing cycles. Those are the items that we are really, really good at.
Yeah, and I guess, of course...
Yeah.
No, I was just going to say, because, of course, as you collect more data, then you're improving.
Exactly.
You're improving the algorithm, right? Yeah.
Exactly. Yeah. So we are as Intellihot gets rolled out and is adopted, it collects obviously data, and we the more data we collect, the more inferences we are able to make.
Yeah, absolutely. Some loads of questions coming for you, so I'll just get through them now. A guy here from the Middle East, he's asking how could he access the product? Are you shipping these products worldwide?
Not yet, but we have plans to do so. I would encourage him to send us an email. It's just sales@intellihot.com, and we would receive all those inquiries there and respond.
Okay, great. Another good question here about ROI examples. Do you have any good examples of clients where they've got payback from this? I know you mentioned to me once about hotels. This is something that they're particularly interested in, right? Because they have to heat and use a lot of water.
Yes. So yes, we have crunched a lot of data from hotels, and what we see typically in hotels is the example I shared with you. Let me see if I can get to it. On our website, we have numerous case studies. Now, the history of AI. Now, on our own water heaters that we build and sell today, we have a lot of this algorithms and technology implemented. So we are able to, even within our own units, talk about how much energy is being saved and what's going to happen to our own component life. And essentially what we did is we took a lot of that stuff and then put it in a device that can now be applied to anybody's water heater or boiler. So the typical things we see in hotels, we see a lot of mismatch between the size of the equipment and what the hotel actually needs. And as a result, they would essentially, we call them short cycle. They would sort of cycle themselves to death and also have excessive component wear from that. And we have gone into hotels where we have cut their operational costs from $20,000 down to $5,000 a month. On our website, we have a bunch of case studies. I encourage you to look at that. The one particular one is the hotel in San Francisco, right outside the airport. And we were able to have a 75% reduction in their costs.
The cost of heating water?
Exactly.
Yeah, wow, okay, great. Next question here. Can it also work for chillers?
It could. Energy is energy. You're always moving it from one side to the other. You you are taking a compressor, you have a condenser, you have an evaporator. The components themselves, if it's not combustion, you have motors and blowers and bearings. So a lot of this stuff is fairly applicable. What I can share with you is we already have a Intellihot 2.0 in development, and that will address several other areas than just water heaters or boilers.
Yeah, so expanding it into other areas.
Right.
A couple of questions here about the app. Will it be available on Android at some point?
It is. It's already available on Android, so you could download it on Android as well.
So if you go to the Play Store, you'll be able to find it there. And if you're trying to search for it on iTunes, it's Intellihot, right? Tellibot.
Correct.
Right. Here, another question. Can data from your systems be routed to edge control on premise without needing to go to the cloud? So I guess what they're asking, maybe it could be used just within the premise, as it were, rather than if perhaps someone didn't want to use a cloud application, they just wanted to host it on their own server.
So I'm going to say a qualified yes. Anything is possible. However, the whole thinking behind this is how can we get a lot of people to adopt it, and how do we simplify installation? So from a technical perspective, yes, I think we could do it. From a perspective of should we do it, I'm not so sure.
Okay. Yeah, fair enough. Can you also suggest using one Intellibot per piece of equipment? That's a good question. So, how does that work in the boiler room? Let's say, I don't know, not being an expert in this, but how many boilers might there be per boiler room, and do you need to have more than one?
Yes, that's a good question. Yeah, so Intellibot, it comes in two different sizes. One is rated for units up to 300,000 BTUs, and we have a larger one that's rated up to 3 million BTUs. And we recommend 1 unit per boiler. So one Intellibot would measure temperatures and flow rates of one particular unit, and it learns what's going on within that unit. And then you can have as many Intellibots as you want in your mechanical room.
Okay. Yep. The next question. There are some facilities like minimum or maximum prisons, mechanical rooms that do not allow Wi-Fi. Will there be an option for a LAN connection on future versions?
That's again a really good question. We get asked that a lot. We are working with several big. We see the same problem in hotel chains as well. Many of them are behind a firewall. Mm-hmm. With the advent of IoT, we expect things to change. We, in fact, offer a hotspot, so you don't have to use your building's Wi-Fi to get out and connect to the cloud. But the specific answer to your question is no, we don't offer a wired-in connection. We did that back in 2011, but it increases complexity of install and cost of install. So we have gone away from it.
Mm-hmm. Okay. Another question here. Is machine learning running on the Intellibot device at the edge, or is it running in the cloud? That's a good question, because I know it's something that we've talked about with other mm-hmm. suppliers of this kind of, about putting intelligence at the edge or having it in the cloud. And, obviously there's a trade-off there. What's your opinion on sort of edge processing?
Well, so we believe in the cloud, and because it is going to take a lot to make anything meaningful, it is going to take a lot of data. And so Intellibot essentially, it does do some minimal crunching inside. Certainly, it does obviously look for gas leaks, water leaks, how often has it happened, and things of that nature. However, predominantly, it pushes all the data to the cloud, and we do all our post-processing of the data in the cloud.
Mm-hmm. Okay. And that's where obviously most of you can get more of the computing that you need, right?
Correct.
Make it easier.
And we do store some data inside, for loss of connection or loss of power or interruption. So the Intellihot does store adequate amounts of data, and it pings the cloud once in a while and pushes all the data over.
How often does the Intellihot actually sample the data? So, I mean, obviously it's trying to sense different things, and how often is it sending data back to the cloud?
The data back to the cloud, I want to say, that's a really good question. I might quote incorrectly, but if my memory serves me right, we do it once every 3 minutes. In terms of the actual sampling of data itself, we do that almost 30 times a second, something like 30 hertz. So temperatures and flow rates. For the flow side, we use an ultrasonic, non-intrusive flow meter. So that data is actually done a lot faster. Temperatures, we typically, 30 hertz is quite fast enough, and we are able to capture all the fidelity in terms of how quickly temperature changes.
Mm-hmm. Yeah. Okay. So there's some real granularity there of data that you can get out of these boilers.
Right, and it's a good question, and I want to share with you this. Typically, when you go to a heart surgeon, the surgeon looks at your ECG and they look at the inflections and the voltages there, and they could tell you have a heart murmur or something wrong with your valve. So we have gotten really good at watching temperatures and inflections in temperatures, and when did they turn, and is there any correlation with flow rate or firing rate, and is there any correlation with lots of other things? So we do the same deduction from inflections and temperatures and correlating it with a bunch of other parameters.
Mm-hmm. Someone here just wanted to clarify. So can the device be integrated through BACnet to a BMS?
So short answer, no. We, again, like for the reasons I shared with you earlier, we want this device to obviously send all the messages in a timely fashion to whoever is listed as contacts in the app. So right now we don't have any, we don't offer BACnet connectivity. And again, with IoT, our sense is we see BACnet again more of a legacy system.
Okay, interesting. And next one here, flow and cycles on boilers. What is the best way to monitor flow meter and temperature sensors? Will this tool troubleshoot inefficient installations? So that raises quite an interesting point, because of course I imagine like a lot of systems, they might not be, boilers might not be commissioned properly. Is this able to kind of sense those kind of inefficient installations?
Absolutely. In fact, that's one of the things that the Intellihot does extremely well. I'm trying to go to the slide. Yeah. Well, the screenshot I have where you see the ideas tab and you see the little summary there. It's talked about, okay, this building has used so many gallons, and here's the temperatures. And beneath that, where you see the recommendations, that is where after crunching the data, for example, if you notice that your boiler comes on more than, say 20 times an hour, and it stayed on, barely a few minutes each, you can look at the flow rates and the temperature rates and the firing and very easily correlate to what is the peak load in your building and how many times has your boiler cycled. And you could make deductions on whether the equipment is sized properly and operating properly. So we do that extremely well.
Great.
And yeah, generally we find, this is a very general statement, generally we find, equipment is terribly mismatched for the building. I mean, they are usually on the opposite end. If a building might need 3 million BTUs, usually we'll find 6 or even 9 million BTUs.
Wow, yeah. Yeah, it's a common problem, I think, isn't it? Just want to get through these questions because you've generated a lot of interest, Sri. Next one here: who owns the data? Does the customer still own the data in the cloud? And also, how do you address any privacy concerns that a customer might have?
Again, that's a great question. As you know, this field and the legislation behind all of this is evolving as we speak. Certainly, our position is yes, the customer owns the data, and we are following any laws and rules that are written. And we have, when you look at our app, we have a pretty extensive. Here is what we do with the data, and here is what we're collecting. The data we even use, it is all normalized, so we don't share any customer name or information. And the information is again pretty much shared back with the customer in terms of useful information, like here's what you can do with your flows and temperatures, and maybe your boiler's not sized properly. But we are again the laws and regulations are evolving, I should say. So we are staying abreast of that and keeping ahead.
Mm. Yeah, obviously there's big changes in Europe as well here about data privacy that are coming up. And a question here about using cellular to connect to the cloud. I think you did answer that, right? That it can have an option to have a hotspot, so you could connect with the cloud from using a cellular connection. Is that right?
That's correct. Yeah, we offer a simple hotspot, so the Intellihot would, through Wi-Fi connect to the hotspot, and the hotspot would go over, 4G or cellular connection.
And here, how many contacts can receive information alerts from the application?
Right now, so when you sign up for the app, you would sort of be the owner of that app, right? So you would get alerts by default. And then under the contacts page, currently we have limited it to 2. And we can expand it to as many as you want. In fact, I'd love to have some feedback on, from people on how many would be appropriate. Right now, we have limited it to 2.
Okay. Yeah, I guess that could be interesting to see how many people, in a facilities team might actually be responsible at any one time for that kind of, boiler issues. What is the accuracy of the readings, and can this be used to replace a typical BTU meter?
Great question. Short answer, yes. It is very accurate. What I mean by very, which is not an engineering term, like I said, it measures temperature, at least 30 times a second. So the fidelity of temperature is quite high. And I want to say in terms of flow rate, it's of the same magnitude. So we have a complete picture of energy that the boiler is putting out into the room.
Mm-hmm. And here, are you monitoring cycles on other people's equipment to monitor inefficiencies? So that's kind of interesting, because my understanding is the Intellibot is like a standalone piece of equipment that you could connect to any boiler. But I imagine, but you also have your own equipment, and does that kind of come baked in, right? So you get this information, you get the Intellibot as part of a boiler as well through your company.
Correct. For the water heaters, we build commercial tankless water heaters. Mm-hmm. For those, pretty much this technology is baked into our software. So if you buy one of our products and go to the screen, all our products are Wi-Fi enabled, so it automatically pushes all that information anyway into the cloud. And if you are interested, we have another app called Intellihot. That's the app that we use to connect to our products, and it has a similar look and feel. But when you use the Intellibot, the robot, that can go behind anybody's boiler or water heater. We can count cycles, temperature rates, flow rates, crunch all that, and give you meaningful information, meaningful data.
And I think you had that slide, didn't you, that showed how you can connect it to a boiler.
Right. I could go back to it. Yeah.
Yeah, that one. There you go.
Right.
Based on the AI data determining that the boiler is overrunning, will it adjust for maximum efficiency or just provide data and you then have to manually adjust the system? How does that work?
Well, that would be wonderful, right?
If it was an autonomous system, yeah.
Right.
Not quite.
So within our units, we do it because we have complete control. But when you apply the Intellibot to an existing, a legacy boiler or water heater, it will provide you the data, but you will have to go and manually either turn down the unit or lower temperatures, and obviously you'll have to do it yourself. But we will equip you with the data and enable you to take intelligent decisions.
Mm-hmm. Yeah, exactly. So as we've said, and with all the stuff we cover about IoT, in this instance, it's about measuring, right? It's about getting that data and then being able to make informed decisions based on that. Yeah.
Right.
One here that I think you did answer, but I guess someone wants some clarification. What was the area of coverage for one unit? And is it a fixed unit?
Could you repeat the question one more time?
I think just about one Intellibot unit, like what is the coverage of that in terms of
Sure.
how many might somebody need for a boiler room with a few boilers?
Oh, sure. So we make the Telebots. Again, you don't have to use it to treat condensate. You can use it with a condensing or a non-condensing boiler. It won't matter. But if you are using it with a condensing boiler, it comes in two capacities. One rated up to 300,000 BTUs. That would roughly be, in terms of kilowatts, I want to say 85 kilowatts. And then the other one is rated at 3 million BTUs, which would be, I want to say, maybe 450 kilowatts. I could be off there, but somewhere around in that region. And then you would want to use 1 Telebot per unit. And then, regarding the previous question, there is some controllability we do offer. The Telebot does come with interlocks. So you could wire the Telebot's interlock to your existing boilers. So should you have a problem, you can prevent your boiler from firing. And then we also provide gas valves and water valves. So you could also turn off the gas supply and water supply to the building.
Okay, yeah, excellent stuff. I'm actually. It's a shame we've come to the end, and there were a couple more questions. So I think best thing to do, Sri, if people have questions for you, how can they get those answered? How can they contact you?
Sure. I'm happy to get emails. My email is quite simple. It's sri@intellihot.com.
Great. Okay. So yeah, and obviously, I guess they can go to the website intellihot.com and get information on you guys there as well.
Absolutely.
From my side here, we had a question about accessing the slides. Yes, this has been recorded, and I'm going to put up the slides and the recording. It's going to be on YouTube. It's also going to be on our website, and also on SoundCloud and iTunes if you just want to listen to the audio. So that's going to be up later. So I encourage you to go to our website and you'll be able to see that tomorrow. You'll be able to get all the information about what we discussed today. And then just a couple of other things. Wanted to say, obviously, thank you to our sponsor, Project Haystack. If you guys are interested in IoT data, I suggest you definitely go and check out what they're doing, the open source project. And they're really trying to work with and streamline all this data, for example, that we're collecting through things like Intellibot. And I think that's about it from us. And just really to say, obviously, to Sri as well, thank you for taking the time today. Really appreciate you telling us about what you're doing, and and really some interesting concrete examples of how it's working.
Oh, absolutely. Thank you for the opportunity. Great questions.
Yeah, exactly. Thanks to everyone for listening, and thanks for the great questions. See you again next month. Thanks a lot. Bye.